All right. So good afternoon and or evening. I won't. There's enough people online. I won't ask folks to go around and introduce themselves and say where they are. But I'm pretty certain we've got folks online from uh, all around all around the country, certainly on the East Coast and the West Coast. And so, afternoon and good evening. I'm so excited to be here today with all of you guys. We've been working really hard to roll out these new curriculum materials in time for the second semester. And so, I'm excited to share what we have with you so far. I'm Nathaniel. I'm the lead regional manager for TEALS in the eastern half of the US. And I'm based in New York City. You you may have heard my voice before or seen my face if you watched the training videos on Canvas this year. So with that, let's get started. So what I thought we'd do tonight is just start by sort of framing what we were thinking when we built this curriculum, what kind of the high level goals are, looking at the pillars we were using, the things we aspire to do, with our curriculum materials, and then we'll actually walk through the 8 units of this curriculum and just talk about the kind of the topics at a high level. And then we're actually going to demo for you each of the major projects for the curriculum, so you can kind of see them and get a sense of them. In fact, we might just go ahead and do that as we go through the units rather than in series. We'll talk about what the materials are that we've produced and show them all to you, and then what mechanisms there are for you to give us feedback, as you're preparing to teach or as you teach the course. And let me just pause. I want to see if someone looks like someone was trying to reach me. Nope, looks okay. All right, let's go ahead. So, as we were sitting down to develop this curriculum, we had a couple goals that we were trying to keep in mind based on the feedback we got from folks like yourselves, folks who are participating on our curriculum squad, on the Piazza forums, and etc. So one thing we knew for sure was that after a semester, most students are definitely ready to move away from the drag and drop programming languages and into a text-based, a real language. So we knew that was a main goal. We really wanted to build on top of what they'd learned using Snap. We wanted to continue the project-based approach like we do in our first semester, and we find that's very engaging for students, especially when we can find fun and meaningful projects for them. We did want to give students who are going to continue on to AP Computer Science a leg up. So we specifically looked for topics and languages that we could use that would help prepare students for APCS. Doesn't mean we expect every student to take AP after this course, but we wanted it to definitely point them in that direction so that those who do go on will be even more successful. So some of the key things we've found that students struggle with when they get to AP Computer Science are basic concepts if they're coming into AP for the first time. By the time we get to AP, we're going to go through loops and conditionals and data types really fast. So if you have an introduction to those things beforehand, that's really useful. A text-based syntax, again, the nitty-gritty of needing to think about really small details like how much space you have or semicolons, punctuation, etc. General problem-solving skills and just the ability to break apart a problem and approach it from different angles. Objects and the object hierarchy, and making use of written references, which is not something we do very much in the first semester. We really focus on other sorts of material. So in AP, it's really important to read the textbook and to read the Java reference. And of course, the other main goal we had was just to make sure this was ready in time for folks to teach it. Let me pause there. Did anyone have any questions about those objectives?
Were you going to have anything about introduction to Unix or the syntax, the interactive versus the file
Yes.
usage?
That's a great point. So in using Python, which is what we did settle on, the students will do some very basic interaction with the command line, and we will make sure, Norm, Bill, I saw your the issue that you opened. So we'll make sure that there's something that we add something to a lesson about that. But it's not a goal of the curriculum that students come out of it as a Unix whiz, but just some really basic ability to execute.
Right, yeah, things like clearing out the screen in the interactive mode, things like that.
Yeah, just some really basic.
Right, exactly. Yeah.
Great. Thanks. Cool. And if other folks have questions as we go ahead and type them into the IM window, and I'll see them there because I have 2 monitors and I can pause for them. All right, we have our curriculum pillars. These are actually the same pillars that we used for for our intro first semester curriculum, but it's worth reviewing them. This is what we aspire towards with our curriculum materials. We want them to be complete, which is to say we don't want our volunteers and teachers to be spending a lot of time preparing materials that are just like everybody else's materials. That's not to say that teams are going to use everything we give you exactly as we give it to you, but if it came right down to it, you could. We want them to be well organized. For our introductory course, we really want this to be accessible. So we're making sure we're providing complete explanations for things since it's a first approach. We want these materials to be adaptable. We know we serve a wide variety of classrooms, so we want to make sure we're not assuming certain background knowledge of the students that not all students have. And we want to make sure that we're providing alternatives, differentiation, and suggestions to help engage students with different needs and different styles. And we really want to make sure that it's easy for our teams to adapt and edit materials as you need to. Finally, these are our starting point. This is the very first time we've offered these materials, and we expect to iterate over time, and we want to set up things in a way that'll make that really easy to do. All right, with that, here are the main materials that we've decided will be involved with this course. The course will be taught in Python 3. Notice that's not Python 2.5 or 2. Whatever. For those of you who learned Python 5, 10 years ago, there are some significant differences, and I'll let Susan address those in just a minute. There are plenty of Python IDEs that you can use and download and install for free. But one thing we wanted to do was avoid needing to install more software in the middle of the year. So there is a web-based IDE called Cloud9 that you can use, and it doesn't require installing anything on the local computers. The students would create an account just like you had in Snap, and we've thought through sort of how you could submit things from Cloud9. Now, you are more than welcome in your classroom to decide you don't want to use that and you want to use something you install locally. As I said, there are plenty of free Python IDEs of various sorts. Right, so idle would be the one that comes with Python if you install it locally on your PC, but again, that requires an installation. So we were trying to avoid requiring an installation in the middle of the year, knowing just how pesky that can be in classroom. So you are more than welcome to use idle. It'll translate really easily if you do so. But Cloud9 is a great free online option. For this course, one of our goals, as I said, was we wanted to get students used to starting to look at a written reference. So we found a free open source textbook called Think Python that's available online, and it actually uses a Creative Commons license, just like our curriculum. So we talked to the author, and we've been adapting and creating sort of an abridged, abbreviated, adapted version of Think Python, which is available side by side right in the curriculum. So you don't have to go anywhere to get it. Students can access it online, or you can print it out.
How many pages is it printed out?
We haven't printed it yet, but Susan, do you have a guess?
I'm trying to guess. It's probably about, I don't know, it's going to be about, I guess, like 60 pages, 60 to 80.
Oh.
It goes into stuff that the course doesn't cover, but it's very, I really like it. It's very nicely written and includes examples and extra problems.
One of the advantages that we have by being able to edit this textbook, because it's open source, is we're adding, and I'll talk more of this later, we're actually adding some Snap examples into the textbook, showing students how they would have accomplished this Python task in Snap. So that's really cool. And I asked a question, will the IDE hold the load of many students in classrooms? So Cloud9 is an industrial strength IDE. And we know of lots of classrooms here in New York City that are using it, so I have no concerns about its robustness. And it should run on any of the same browsers that would run Snap, which is to say, a recent version of Chrome, Firefox, or a latest version of IE. And of course, if you encounter something else, please let us know. The lesson materials are going to be available in a Git book, just like in the first semester, and we are licensing them under a Creative Commons share-alike, non-commercial, I don't know what BY means, 4.0 international, but it's the same license, which means you are free to reuse and remix them to your heart's content. And we'll talk about that a little bit later. All right, so let's dive in and actually start talking about these units and what's covered in the course and look at some of the actual examples. So I'm going to switch between slides and actually looking at the curriculum itself. So if you don't have a screen sharing connection, you can go to the TEALS dashboard, and if you scroll down to resources, you'll find that the second semester curriculum has actually been posted in its current form down there, and so you can follow along. So we'll start with Unit 1, and Susan, who was a TEALS volunteer herself, has been working with us, Susan Goldblatt, as the lead curriculum developer, and she's on the line today. So I'm going to defer to Susan to show us some demos of the projects and talk in a little bit more detail about some of the units. But we'll start with Unit 1, is really just a basic introduction to the idea of a written language, right? This is the first time that most of your students will be interacting with any sort of written syntax. So we're just getting them, hello world. We want to show them the difference between, in Python we have the interpreter, and you can in real time just kind of type things and see what happens, versus the script mode, interactive mode and script mode, where you can write complete files that reference each other and then execute those files to run your program, which is more like what you'll see when you go to use Java in the AP course. So we walk through a series of those, including just getting the IDE set up, getting used to how we're going to submit files this semester. One of the things we wanted to work in every unit in this curriculum is debugging. So you'll find in just about every unit, if not every unit, we have a lesson where there's a debugging activity right in the lesson. And we also have some quizzes built in as well, now that it's a little bit easier to quiz with text-based. So as you can see, we have here a Git book. It looks similar to the first semester, but it's obviously all new. And it's set up very similarly. You have a page for each lesson, and then any associated materials are available in line. In the first semester, we provided anything you might want to print out as a Word and PDF file. We do intend to do that, but right now it's not our top priority to get that done. So we will come back to that. But in the meantime, you can, of course, just print out any of these pages if you need things printed out. So Unit 1, Susan, anything you want to say about Unit 1?
No, I think you covered most of it. It's a basic kind of like intro. I would say a lot of it also talks a little bit about like using Cloud9. I think that's like the first couple of lessons are just like, how do you sign in and how do you type things into the terminal? And then it gets into a little bit of the really kind of like going from Snap and trying to learn from there. And the project Mad Libs it's pretty fun. I think it's fun. It's basic. The problem, I guess not the problem, but the kind of a buffer we ran up against is all the projects are text-based. So trying to find a fun idea of how to like take an input and turn it into a full story and concatenate strings and kind of do all of that. So that's what Unit 1 is all about.
Susan, do you have a demo you can show us of the Unit 1?
I do have a demo. Yeah, I don't know the easiest way
just
to
go ahead
do
and
that.
If you're comfortable, you can just go ahead and share your screen and take over from me.
Yeah, that's no problem. Okay, present now. Oh, okay, present.
Cool. About the quizzes, and is saying it opens for everybody on the web. Yeah, that's what I was saying. Right now, we haven't yet converted the Git book pages to PDF files or Word documents. So if you do click on those links, you'll just get the page within the Git book. But you can, of course, print that page if you want it on paper, or just copy it and paste it into a separate file. We do intend to publish those as PDF files or Word documents, but we're focused right now on just getting the actual curriculum done first, and then we'll go back through and create some of those extra resources. Oh, I see what you're saying. interesting point. Yes, we will have to move those. That is, the students will have access to the quizzes. Yes, yes. Good point. We will move those to a protected spot, probably on the SharePoint side of things. Yes,
funny.
I will open an issue on that. So go ahead, Susan, and walk us through this example while I make a note of that.
Yeah, sure. So this is Mad Libs, and as you see, the idea is you take an input. If anyone's familiar with Python 2.7, which I think is the most commonly used one, here's one of the not the biggest difference, but instead of raw input, it uses input, but it doesn't allow you it'll take everything in as a string, which is kind of helpful in this time because you have to think a little bit about if you actually want the int, you have to convert it. So that's like a helpful thing. We don't use it in this lesson, but I think it gets used in unit 3 a little bit further on, but that's just something to think about. So you pass in, they ask for proper nouns and places, just like a game of Mad Libs. Right at the beginning of the game, and then at the end you concatenate all the strings and print out a story. So to run this in Cloud9, you have to do Python 3, and then it actually does it creates like a little folder for you. So if you do the commands like ls, it'll show you all the files. So Python 3, unit 1, madlibs.py. So this is my example, a day in New York City. So we don't have to go through all of this, but basically you keep on entering in things, and then at the end it prints out a story for you.
I love how
unit 1.
I love how New York centric your story was right here. You know, Dwayne Reed. No one knows what a Dwayne Reed is if they're not in New York City.
I guess it is. I didn't even realize it. Well, it's up to you because I tried to keep it really basic. So it's just like, oh, what a fun day in New York. But creating the Mad Libs, I actually think that's probably the hardest part. So it might be helpful to. Yep. I think the students won't have a hard part with that, but for me, I was like, I don't know.
So Joe from Oakland Skyline asks, can we share the source example implementations of the project? Yes, we will put the source files in the same place that we move the quizzes to, and we will tell you where those are. Again, it'll probably be on the same SharePoint site where the AP materials are, and we'll make sure there's a pointer there. Those are behind a login, so even if students can have the link to where those are, they won't be able to access them without being able to log into the TEALS dashboard. And Susan's just going to go quickly fill in this Madlib so we can see it print out. So the fun thing here is, of course, there's a planning step that's important for the students. They have to write their story. And so that's something they would do separately on paper or in a separate program, and then convert it and figure out, okay, what are the words I want to pull out? What variables do I need? So there's a great kind of built-in planning step for this project, which is one of the things I love about it. Awesome. Thank you, Susan. I'm going to take control back over for a moment, and you can get number 2 set up. So that is unit 1.
I got a quick question. Is this going to envision to be individuals or teams?
No, I don't think we have a specific point of view on that. I think any of these projects certainly could be done as a pair project. They haven't been designed with that in mind.
Mm-hmm.
Cool. So the second unit is data types. Now, in the first semester, Snap has data types, but they're really subtle and they're really kind of transparent. You don't really notice you're using data types much in Snap. It's not something we explicitly talk about in the curriculum. But it is something that's going to be very important if students go on to take AP, and of course it's very important to computer science. And we thought a fun and engaging way to introduce students to the idea of data types was to do a one-day mini lesson on binary and just kind of talk about the iron a little bit, talk about the silicon, talk about, how is it computers represent data. There's a million activities and ways that you could do that. In the curriculum, we've of course included a complete lesson that you can use. You may have other ideas about how you learn binary and what you want to do with binary, but basically all we're doing with binary is talking about storing different types of information as zeros and ones and helping students see how you might store different types of information as zeros and ones, so that as we start talking about data types, you have a common frame of reference you can refer back to and say, ultimately this stuff's all stored as zeros and ones. And the computer needs to know how to interpret each block of zeros and ones, and that's why data types are important. So it's a nice way to frame data types, and it's also just a nice kind of break from, okay, we've just done a bunch of text-based syntax and coding, now we can do some fun sort of more unplugged stuff and conceptual stuff. So throughout the rest of Unit 2, we're going to talk about what are data types, how do we move between different data types. As Susan alluded to, in Python 3, when you take user input, it always comes in as a string, which means if you want the user input in any other form, you have to explicitly cast, which is a nice crutch because it'll force students to think about data types. So we'll introduce the idea of data types and casting. Really all we're going to talk about is string versus number, float, and integer. After that, we'll move on and introduce Boolean expressions. Now, students are already familiar with Boolean expressions from Snap. They've used them a lot. So you have a lot that you can refer back to as you are going through these. Of course, once we have Boolean expressions, we can move on to conditionals. Again, students have already used conditionals in the first semester. We're just teaching them new syntax around it, so it shouldn't take a lot of time. Similarly with lists. Lists are another data type. They're a complex data type. And students already know all about lists because we did Hangman in the first semester. So again, lists should not take a huge amount of time. It's more about translating what they already know into a text-based syntax. So we have a few lessons on lists, and then we get to the last topic that we cover is a very basic idiom for a loop. Basically, just a while loop that can run a game iteratively. And again, students have seen loops in the first semester, so the concept of a loop isn't brand new. The concept of a while loop or a forever loop that you're going to use to run the iterations of a game won't be particularly new or novel. But it is important because that sets us up for our project for Unit 2. So Susan, would you like to tell us about the project, and then we'll take a look at it. Oh, you're muted. Uh-oh. We may have lost.
Am I good now?
Oh, you're good now. There you go.
Okay, I just muted and unmuted again. So the idea behind this project is it's a text-based game like Zork. This one specifically is based off of an internet game where you try and get to a dragon. So there's the idea is there's a bunch of levels. So I put 3 in, and each there's different rooms that you go into, and you say left, right, and basically you try and defeat the monsters and get to the prize at the bottom of the maze. So it's really fun because it uses all of the different. It accesses a list, and you have to use the user input and conditionals, and it runs in a loop, but you don't need the function. So it's a really great project that actually does a lot, but doesn't really cover that far. So
I want to highlight a couple details, and we'll take a look. So one of the cool things about this project is this idea that there's a map, and students are going to, you're going to help the students understand how they can represent the map of this game using a finite number of variables, each containing a list. So in this case, our map is essentially a 3-dimensional space, but each consisting of 3 floors. Each floor is a single hallway, 1 room wide and 3 rooms deep. And each room can contain one thing, and that's what we represent within this list. Since we have a known finite number of floors, we don't need nested lists, which we haven't really talked about yet. We can just represent each floor in a single variable. We need additional variables to keep track of state, like the user's current location and floor. The users will give us commands to tell the game what you should do next, and then the game will respond. So, cool. Susan, why don't you show us what that looks like?
Sure thing. And the interesting thing too, I think, about this is the accommodation is like if the students are moving quickly, using a nested list and list of lists is actually probably makes a little bit more sense for this project. But like it works the other way. So I think that's a really cool way for students to kind of take it and work on do something that's a little bit more difficult. So I like that because I think that's nice. So here's the program. It's just runs not in a function, just has a basic while loop and a bunch of variables declared up there. And here we go. So you can do, there's a bunch of commands. You can say help. Oops. Oh, it's called commands. I named it something commands. Okay. There we go. So you go left and you grab the sword. I actually know the board really well. So I can win the game very easily. You defeated the monster, but there's a bit of logic, if you, like, kind of depending, so if you go, yeah, and then since you don't have a sword, you should die, so, I have been fatally wounded. But basically the idea is here you go down the stairs, it takes you to the next level, and then you get to the prize. So I can play it again and win.
So basically the loop of this game is keep asking for a command, update the user's position based on the command, check the user's state and the state of the room, and follow a certain set of rules about what should happen given the user's, what the user is holding or not holding, and what's in the room or not in the room.
Exactly. And then if you go back, I think another key point that comes up in this project is some list. So we cover append. So you have a pocket and you add things to it, you take things out of it. So that's kind of like a thing that the students have to keep track of, and the fact that if you update a list in one place, it stays updated. Which is something that's I think it doesn't get, like, the issue of that doesn't really come up in this project, but it gets brought up later, so it's a nice, like, setting stone to be like, that's what happens with lists. And talk a little bit, as functions come up, that becomes, like, much more complicated. So.
Cool. All right, I will pick up where we left off, and you can set for the next topic. Here we go. So, moving along, we get to Unit. So, Unit 3, we're going to go back to functions, and of course we've seen these in the first semester as well. But they didn't look like functions, they looked like blocks. So, again, a lot of what we're doing now is translating from Snap to Python. So, we'll look first at some library functions that are available in Python, just like library blocks you had in Snap, and then how do you define your own functions, the idea of returning a value versus printing a value, and of course that all has analogs in Snap, say versus,
anyway, this is a TEALS thing.
I'm forgetting what the word is.
But the main thing
so, I'm going to mute someone.
How to install the drivers. So, like, the one very characteristic
There's
thing,
someone,
like, that's
Joe, is that you?
Yeah, but the driver one.
Yep. I'm drunk with power. So, as we're talking about functions, we're going to talk about function scope. That's something that doesn't come up much in Snap in the first semester. It's there, it's in the background, but it really doesn't come up very much if you don't want it to. And really focus a little bit more on debugging. And our project in Unit 3 is Oregon Trail, which is one that hopefully students have seen before or played before. It's a perennial classic. So you can see we do, this is a shorter unit. Unit 2 is kind of long, so this one's a little bit shorter. You have your built-in functions, user-defined functions, return versus print, scope and debugging challenges, and then we get to the Oregon Trail. So I think most folks have probably, what was that? I think most folks have, that file link probably shouldn't be there anyway. Most folks have probably played Oregon Trail, so this will be another sort of text-based adventure game. So students will have, because we just did a text-based adventure game, students will kind of understand the bigger mechanics sort of the, oh, I need a loop and thing that's going to be turn-based, and there's going to be variables to keep track of my state. But this game is designed to be really, really annoying to build unless you use custom functions. So with that, I'll hand it over to Susan.
Yeah, sure. So the main thing that comes up with custom functions that's helpful here is the adding a day. There's a couple of logics that you have to check when you add days in this program. So the idea is you start on March 3rd, and you have to get to Oregon by the end of the year, and you have a certain amount of food and you have a certain amount of miles that you have to go. And so there's a bunch of functions here that get repeated. So this add day is the biggest one. And if a student wanted to not use functions, it would just take forever. The code would be really complicated. And you already saw the monster maze code was getting a little bit long, and this one is just going on. It would go on forever. So it's really important for them to kind of see the use of that. The other thing that comes up in Oregon Trail is this idea of global variables. So we had a bit of an issue with Python 3. The way that it works is variables are described globally. So we have a whole lesson on scope that we brought in, and all these variables get declared as globals at the beginning of every function, which allows this program to work the way that it does. So basically, the same interaction as the monster maze. You make choices of what you want to do, but it's just a lot more using the functions. It's easier to see kind of the flow of the program. So that's I guess the idea with this project is to be more organized, think about how functions relate to like what you're actually doing specifically in the code. So with this one, you can type in travel, and then you look at your status, and you should see your health is 4, you've traveled 100 miles, and it's the 9th of March. So you can hunt, and you can rest, stuff like that. I think, there's a couple of trickier things, but I think overall the students should enjoy it. There's also the random library gets used, which is a really great way. There's a lot of opportunities to use the random library, and there's a lot of opportunities in this project to get really creative and really like true to the game, because half the time in the game there's like dysentery and like all these like crazy things that can happen, and the basic version doesn't have that, but if students wanted to, it's a really easy way to have fun with this project and take it to a harder level. So that's Oregon Trail.
Awesome.
Yeah.
And again, as folks have questions, please do type them into the chat window and we will address them. All right, that takes us to Unit 4, which is for loops. So in Snap, we did lots of loops, but the loops are forever loops or repeat loops. There is a for loop in Snap if you load the special extra function sprite that we try to discourage students from using very much. In Python, some sort of the best kind of loops, the kind of loops that you're going to use a lot of are sort of for loops and for each loops. So we're going to focus on those in this unit and taking what students know about looping and applying it to something that works well in a text-based language. So you'll see we just kind of have a recap of loops, a lot of just sort of simple labs where we need to go through a list and do something. And we're looking at the different idioms that might come up as you do looping. So loop through to print out, loop through and do something with each value in a list. Loop through and mutate each item in a list. Loop through and do some sort of summation or something where you're accumulating as you go through the list. So different idioms that require looping. And we do get into a case where we actually need a nested list. Again, I think we saw nested lists in Snap. At least most classes probably did at least one nested list in Snap. So that'll translate okay. This is one where it might actually be a little bit easier in text than it is in blocks. And all of this builds up to another quiz and a basic version of tic-tac-toe. This is not a complete tic-tac-toe, but it's you can play sort of one game. So, Susan, you want to talk about kind of the limitations of this and what the idea was?
Yeah, so this one's actually the tic-tac-toe solver. So I think in the previous lessons, the project is to create the tic-tac-toe board, which is a list of lists to kind of get the ideas of how tic-tac-toe works. And then the solver, the project goes through and figures out how to solve a tic-tac-toe board, which is, I think, all the people who are have done a coding interview is somewhat of a classic question. I've had it on interviews before, but it does a good job because it requires you to think like in a couple of different ways. Like you need to have the board, the concept of the idea of the board. So knowing that you have a list of lists, and you also have to think of how you're going to go through in each direction that you would check to win tic-tac-toe. So like horizontally, vertically, and diagonally, and reverse diagonally. So it includes a kind of for loop that you have to make sure works in the right way. And the way that I've written it out here, it uses a single function to check all the directions, which I type out as a way that students could think of it as like an extra credit because it's not the most obvious solution. But yeah, so this basically, you give it a couple of boards and it just checks and tells you if X is one, O's ones, or no one has won. So it's not interactive, so it's less a game, but it requires a couple of different Boolean statements, and you could make it into a game.
Right, exactly. Yeah. Another great extension for students who are moving a little faster is, okay, take your tic-tac-toe solver and build the rest of the game. Build the part that, allows users to actually participate in a game. And heck, you could even build an AI if you wanted to play against.
Yeah, the AI for tic-tac-toe is easy enough, so
okay.
It would be a fun one. So that's what this one is. Pretty simple project and fun. I actually think it's a little bit more difficult conceptually because there's so many different kind of like. There's a lot of like it's a little bit more heady than the other ones have been.
Tic-tac-toe in the second semester reminds me a little bit of Hangman in the first, where the game seems simple. Every kid knows how to play tic-tac-toe. Most kids know how to play Hangman, but so the students will grasp what they're trying to build, but when they go to actually do it, they'll find that there are a lot of subtleties hidden in what they're trying to do, which is fun. Okay, Unit 5 is really cool. We discovered this great new tool from Georgia Tech called EarSketch. Now, Unit 5, there's not really any new concepts taught. We're basically taking all of the stuff we've learned in Python so far and synthesizing it using a different tool, a different environment, a different modality. That means you can skip Unit 5, but I think a lot of kids are really going to enjoy it. It also means if you have trouble making the technology work, you can skip Unit 5. So here's what EarSketch looks like. It's an integrated development environment where you have Python, some tutorials and instructions over on the right, and this digital audio workstation. So if you've ever done audio editing, this should look familiar. It's kind of like you could have one or more tracks of audio that you can solo or mute. You have some representation of time. This is a musical representation, so you have measures. Each of these numbers is a measure. Measures are subdivided into beats. And then you can place audio samples in time on any of these tracks, any of these channels. And EarSketch comes with where's the library? Is that one? Nope, that's the book. Somewhere there's a library. Coder.
And it's also nice because it has a large associated text, like reading that goes over everything in the side panel, and
here we go. Yeah,
like in-depth explanations.
So there's a library, which is being a little bit slow to load for me, probably because I'm presenting. And there's thousands of sampled sounds, whether they're individual instruments or beats or sung lines, instrumental lines. You can also add your own sounds. And basically, you're going to use Python to place these. Oh, I think I just accidentally did something I didn't intend to do. Whatever. You're going to use Python to, so you're going to import the EarSketch library, initialize your workspace, and all this is explained in the lesson plans and the text. And you can load a sound, a beat pattern, and you can place beats into the timeline. You can place the sounds into the timeline. There's lots of different ways you can do it, and it's all explained here. But the net effect is the students will build these projects, and they'll end up with interactive audio. And if you could hear my sound right now, you'd hear a really thumping bass line and drums. So this is a totally different way to use code than anything we've done up to now in the class, right? It's not quite a game, it's music. So we got this from the Academy for Software Engineering here in New York City, and they've really loved, the students who've used this have really, really loved it, and it's been a favorite. But the good news is here, if you do have problems making the technology work or you're tight on time, this is essentially an optional unit.
Yeah, I got a quick question. In the lab here I was looking, it's got some constants, all uppercase and so on. I'd put a issue out there about conventions. Are we going to try to enforce conventions to kind of prepare them for AP also?
So specifically, I think that's going to be so in the rubrics for various projects. When there are conventions that we think are really, really important and necessary, they'll be worth points on projects. But it's certainly up to you in your classroom to figure out sort of the culture and the conventions that you think are super important. When it comes to the AP course, the College Board is very clear on which things are on the test and which things are optional. So I think that's kind of the stance I would take here, is just be clear. You can give students, hey, we suggest you do it this way, versus you must do it this way. One of the nice things about Python is indentation is actually meaningful. So in Python, you must indent on an if statement. You must indent in a custom function or a loop, or it doesn't work. So that's a nice way to enforce indentation. And so when students go back to Java, where indentation is optional, hopefully they'll have good habits. Cool. We're running out of time, so I want to make sure we get through the rest of the units and a few other things. So let's move right along to Unit 6. Unit 6, Python has a wonderful, wonderful data structure called dictionaries. A dictionary is essentially, oh my gosh, I'm blanking on the word I was looking for.
Hash table.
Hash table or an aliased list where you have key value pairs. So think JSON, if you're familiar with JavaScript, is very dictionary-like. So Python has dictionaries. They're similar to lists in a lot of ways, but they're a little bit more powerful, a little bit more fun. And we figured, what's the point of learning Python if we don't talk about dictionaries? So we have a short unit on dictionaries. Once you have dictionaries, you can do cool things, because you can have a key value pair where the value is a list. So you can have a dictionary that contains lists. That's really cool. And some paradigms here. And the project for Unit 6 is the game Guess Who. Susan, you want to talk a little about Guess Who?
Yeah, basically you have a dictionary of the names to a list of values, and the user interacts with the program and makes a couple of guesses, asks like what the hair color is, and from there tries to guess what the person is, just like how the game Guess Who works, but a little bit text-based. I can show you, but I don't know if it's, I think we have a couple more things to cover, so I wasn't going to.
Okay.
But this is a fun one too, also because I think that dictionaries and lists of dictionaries points really well to working with like Google's the way that like Google search works. So I think we mentioned that somewhere, and I really like that's like my favorite concept that I ever learned when I was learning programming. So I always like to bring that one up as like a concept that is covered with dictionaries and lists of dictionaries. So anyway,
awesome.
Shout out to that.
Cool. In Unit 7, this is where we talk about objects and classes. Python does have support for classes. It's a little bit more of a loose typing than something like Java, but it's definitely enough to get the idea across. It's just not something that a lot of folks actually, well, some folks use all the time in Python, and other you can get by in Python without ever defining a class. So unlike Java, where you have to have a class. So we're going to introduce the concept of a class, user-defined types, custom methods, And we go as far as inheritance, and that's as far as we go. We're not going to get into some of the more advanced object-oriented concepts. We'll save that for AP. These 4 labs are probably deceptive. I doubt that you'll get through these 4 in 4 days, just because these concepts are kind of mind-bending if you've never seen them before. And in something that sort of foreshadows what will come in the AP course, the final project for Unit 7 is a sort of modified Pokemon game. I'm not sure how familiar you folks are with Pokemon, but your students are very familiar with Pokemon. And in the Pokemon universe, there are all these creatures, these monsters, and they belong to different categories. So there's the grass type and the fire type and the water type. And each one has different characteristics and properties. Each type has certain properties that are common across that type, and then each individual Pokemon has properties that are unique to that Pokemon. And essentially, in a Pokemon game, you're collecting the different types of monsters, and then they battle against each other. And in each battle, there are different actions that the player can take with their Pokemon, like attack, heal, or swap out one monster for a different monster if you want to do something different. So in this game, we have a very naive artificial intelligence. When the user plays, they'll be playing against the computer, and the computer is going to follow these basically randomized logic to determine how it's going to play. So 2/3 of the time it will file. I think that's a typo. Fight, maybe. 1/6 of the time they should heal, and 1/6 of the time they'll switch Pokemon. So it's all totally random, but it'll still be somewhat convincing when you go to play it. So in this game, when you go to build it, you'll need to implement the general Pokemon class. You'll need to implement the classes that inherit from the general class, and then the classes for each of the individual types of Pokemon.
And then this project has starter code as well, because it's a bit more lengthy than any of the other projects. When we planned it, we didn't. Yeah.
Do you have that? Can you show that to us today?
The starter code?
Yeah.
Oh, the Pokemon code's definitely done. I can show that, but the starter code, I'm not quite sure where. I think it's probably in my Sublime text. I can show it if you want.
That's all right.
But I know that it's all there. It's probably just not linked in the.
Oh, here it is. Here it is.
GitHub
Yeah, here
directly.
it is. I don't know if it'll open.
Yeah.
I don't know if it's linked correctly yet, but yeah, it's going to open as we'll see if that opens on my computer or not. But the idea is we're going to provide a starter code so that for the project of this scale in intro class, students don't have to start from scratch. Okay, this is not going to be helpful. Thanks, Notepad.
Oh.
That's not any better. Okay, we have a question about the debugger in Cloud9. I'm going to hold off on that question just because there's a couple things I want to cover before we get there. But that's Unit 7 with Pokemon, their starter code, so hopefully that'll help. You'll also notice that unlike all the other projects we talked about so far, we've really emphasized checkpoints in this project. It's going to be really important when you go to do it. You may want checkpoints for some of the other projects, but you're definitely going to want them for this project. Unit 8 isn't live here yet, but Unit 8 is really just a parallel of the final unit in the first semester. We're going to do another final project. Just like in the first semester, it's students' choice, but it's in Python this time. So they'll go through a design and brainstorming process, plan out their work, and then implement their project. So similarly to the first semester, I would recommend, if you're tight on time, cut out a unit or two so that you have time to get to the final project, because students will always appreciate the opportunity to be creative and build their own project. So let's stop there with kind of the walkthrough, because I want to talk about a couple other topics, and I know there's a question or two in the comments. So materials, as I mentioned, everything I've been showing you, the Gitbook is all available today from the TEALS dashboard. However, it is not done. Specifically, you will find Units 1 through 7 are all there. Units 8 will be live within the next few days. Again, it's mostly the same as the first final unit. So Units 5 through 8, we're still adding some detail to the lesson plans. Everything you need is there, but we'll be adding some detail. We figured people won't need those for a few more months, so we're going to get it right. Some final copy edits and corrections. This stuff's basically untested code at this point, so we know there's mistakes, we know there's typos, we know there's probably issues. And I'll talk about that in a minute. One thing we know we want to do is continue adding more snap examples both into lesson plans and into the readings. So we will continue to do that as time goes on. And our plan ultimately is to move the associated readings. I didn't show those to you, but let me show those to you. So right now the associated readings are all at the end of the Git book on a single very long page. One very, very long page of this Git book. Ultimately what we plan to do is actually make a Git book of its own for the readings, so it'll have its own table of contents and it'll be easier to just kind of go to a certain section and page. And then we would just link to it from here. For now, we'll go with this, and we'll let you know when we make a change. This will get the job done. So we need your help. As I said, this is largely untested code. Unlike the other two curricula that have been done many, many, many times, this has not been. So all of the source files for the lesson plans and examples and everything is a GitHub repository. The URL is here. You'll also find this URL in the lesson, in the Git book itself, although it occurs to me that we should not do that, because if we're going to put the quizzes and example files into the repo, we'll have to think about that. So we'll have to think about protecting some of this stuff. So two things we ask you to do with GitHub if you're inclined. One, if you find issues, you can go to this GitHub page and open an issue in our issue tracker, and that way we'll know about it and we can try to fix it. If you're feeling more ambitious, you can fork our GitHub repository, and of course if you don't know what these words mean, that's okay. And you can actually make the fix yourself and submit a pull request containing that fix, that change, and that way you've saved us the trouble of fixing the issue that you found. Either way, we're happy to accept your contributions. We do ask that you should keep if you make pull requests, keep them as atomic as possible. So don't put 10 different fixes in one submission, because if for some reason we don't want to accept all 10 of them, you've made it hard. So try to keep them in separate pull requests. It'll be easier for us to manage that way. Okay, two questions I saw in here. Let's start with the second one first. Do projects have auto graders? No, not right now. So that's a great idea, though, and if anybody makes progress on those, we are more than happy to help share that out. And if we have some extra time and resources, oh, Joe can write some, even better. We love that idea. Please do, please share. Keeps the grading fair, absolutely. Although, of course, if you are auto-grading, you do always want to reserve some points for style. You do always want to read the student's code and make sure that it looks like they wrote it themselves and whatnot. Yes. Question from Mark. Susan, you'll be a good person to answer this. How is the debugger in the Cloud9 IDE? Can students set breakpoints and view variable values and step through code?
Yes. So the debugger in Cloud9 I haven't used extensively, but you can set breakpoints. You can run the code, and I think my favorite thing is it does like an inline correction. So if you have a typo or some sort of spelling issue, or like you don't put a colon somewhere.
Yeah, can you demo this as you're talking?
Yes. Yeah. I haven't. Let me get this going.
Yep.
I haven't set up and run the debugger because there's been no need, like strong need for it, I guess. But see if you type, if you don't have the parentheses.
Hang on one second. Yeah, wait till
okay.
It's still loading for some of us. Okay, I think it's mostly
okay.
Come in, go for it.
Okay, cool. Yeah, so if you see on the screen here, I took out the parentheses, and it tells me that it's an invalid syntax, and I put it back in, and the invalid syntax goes away. So in the debugger mode, I'm trying to figure out, just like with any IDE, it just takes a second to figure out where all the things and shortcuts are, but I distinctly remember so you can show the debugger. There's definitely a debugger mode. I haven't played around with it too much, but I think that, here we go. And then you click the debugger, and then you set breakpoints. Yeah, here we go, add a breakpoint, and it comes up in the side. So it's a really nice, the IDE itself reminds me a lot. I use IntelliJ, and it reminds me kind of that whole environment. So I really think it's
That
nice. Yeah.
said, this is using the debugger, something that comes up a lot in our AP classes. Now, in AP, we're kind of on a race against the clock because there's the AP exam in May, and if you don't cover all the concepts that are on the exam, students won't do well on the exam. We don't have that constraint in intro. You can go whatever pace you want. Using the debugger is a skill you will need to teach, just like any piece of syntax or any other tool or skill. So if you do want to use the debugger, just keep in mind that it'll take time to teach the students how to do it. They'll need a chance to practice it. It's an extra degree of complexity. So one of the things I like about Cloud9 is it has a lot of these features, but they're kind of hidden and tucked away unless you go looking for them. So even right now,
is there some documentation on that on Cloud9 and Python and debugger and so on?
For the debugger specifically, I'm sure there is documentation. Cloud9 has extensive documentation, but let's see if we're looking right now. Yeah, under support, the support menu, I imagine, is where you would find that. Susan, can you click on support at the top?
Mm-hmm.
Yeah, okay.
There you go. Get Cloud9 documentation.
And there's a YouTube channel, and they're trying to be like a remote programming environment, so they like run on boxes and that you can push things to Docker. So I'm pretty sure that they have a pretty developed documentation running and debugging their code. Yeah.
There you go. So there's some documentation right there. Okay. So it is it is now 9 o'clock here on the east and 6 o'clock in the west. Before folks go, I would really love, it's hard to do one of these presentations. Everyone's silent most of the time. I'd just like to get some general feedback from folks. Is this what you were hoping for? Is there stuff you're not seeing? Are you kind of feeling nervous? Are you feeling excited? Where are people right now? You can type, you can talk. I'd love to just get some quick feedback. A couple people typing, that's great.
I definitely think this is very helpful. One of the things I think that are missing is the presentations, or I understand we went quickly through the units, but any type of material to visualize, present to the students in a lesson format.
Yeah, so cool. So the lessons, right, similar to what we did in the first semester, the basic materials we're providing for each lesson are a lesson plan and then handouts that students might use for a do now. We actually are providing do nows. That was a big piece of feedback we got from the first semester. So each lesson has a do now and then any labs or additional handouts that you need. So the question was around like slides and presentations. We haven't prepared those at this point. However, we do have another teacher who's been contributing, actually from outside the TEALS program, who's been helping us with the curriculum, who actually just mentioned that he's planning to do some of this stuff in his class that we're building, and he's happy to share back any presentations he designs. So we will definitely try to build that up as we go. If any of you make slides or presentations that you think are great and want to share, please share them and we'll make sure they get distributed. Let's see, Mark D says, one concern is, will the students miss graphics? I wonder if they will dislike all the text-based programming. Text-based programming is fine, but they'll miss the graphics. Yeah, so we're not sure. We did talk to a bunch of other teachers who do text-based stuff. We did a lot of graphical stuff in the first semester. So we'll see. One of the reasons we put ear sketch in where we did is it breaks up the unit, breaks up the semester. So right in the middle we have a whole unit where they're off using a very different tool that's audio-based instead of visual and instead of text-based. So yeah, we're aware of it, and we'll kind of see what happens. I think down the road you could imagine, if you were doing a year-long class, kind of alternating between Snap and Python. So you kind of move between the two. But that wasn't going to be possible this year since this wasn't built for them.
Python has Turtle in it, right? That you can draw some graphics, at least crude graphics.
Python doesn't have that built in. There are some libraries. Pygame is a good library. Those libraries, though, you would need to locally install into your environment.
Okay.
Okay.
Yeah, it was a big problem we had of trying to find the right online editor, given the parameter that we couldn't download things, because not every school could download something. And there's few Python editors that have like a text-based language that also include a visual component that are allow you to save your files and do a bunch of the other stuff. So it's a little bit difficult, but I would assume if a school can download something, Pygame, there's a really good, like a bunch of resources that come with Pygame. There's a book we can link to it that has just a bunch of really fun, like Hangman and different options for it. That's not too difficult.
So one question was to give an example of a do now. So here is do now for lesson 2.04. Create a schedule program. Given the hour of day, print out where you should be. If you're not doing anything else, you should be sleeping. Here's an example. What hour? 12 p.m. You should be at lunch. So one simple task that students can get started on. With these do nows, and this is actually a great point that we're going to put in writing at the beginning of the curriculum, most of the do nows are going to take more than 5 minutes. The idea here isn't that you should let the students take an infinite amount of time to do it. It's that it's a focusing task to get them started and get them thinking. And in most lessons, you're going to go on and then do that do now or review that do now as a class anyway. And it's going to lead you into the lab. So the goal here isn't that every single student needs a complete program before you can move on. It's more get the students started because this is going to help them think about what we're going to do today. In this case, it's conditionals. We haven't actually talked about conditionals yet. So how are they actually going to accomplish this task? It'll be interesting. Cool. And so a lot of the do-nows are also sort of asking students to guess ahead a little bit or to refer to the associated reading that they were supposed to have maybe done. And some students will do, some students can look at it as they're going. Looks like I have one more. Let's see.
Yeah, there's a question about the algorithms and using sorts.
Yeah, we did a little bit of algorithms in the first semester in Hangman, and it'll definitely come up again in AP, but we didn't think that was sort of the highest priority for us in this collection. And as Joe points out, Python has a built-in sort function, so that would be a nice little cheat for the students. All right, well, so the curriculum's out there. Within the next 2 to 3 weeks, so our understanding from surveying you folks is that there's one school that started the second semester this week, and most other folks don't start till at least a couple weeks from now, if not later. So we will definitely be making sure the first several units are completely 100% ready within about 2 weeks, and make sure the rest of everything gets taken to completion as well as soon as possible. Of course, completion is not completion. Please submit issues. Please contribute suggestions via GitHub. And we'll keep this evolving, and it's so exciting. I'm excited to see where this stuff goes. You guys are pioneers of this curriculum, so let us know how it goes. We intend to support you as much as we can. Thanks everyone for making the time today. If you have questions, you can always post on Piazza. You can email me at nathaniel@tealsk12.org, which I just put into the chat window. All right. See you, everyone.
Bye. Thank you.
Bye. Thank you.
Thank you. Bye-bye.